Let's look at Rogue DHCP servers. So here we have a small portion of our network. We have our official DHCP server someplace out on the network someplace. When our client comes online, it of course sends that request out to the DHCP server. Now, when it does that, it actually is sending a broadcast message to every device on the subnet to get it there. Let's look at that again quickly. We'll rewind that, and when that DHCP discover message goes out, the destination IP address is 255.255.255 with all Fs in the destination MAC address field. So what that means is that when our discover message goes out, all the devices on our network hear that discover message. Our router receives that discover message, uses the helper address then to forward it on to the DHCP server. The problem that happens here is what happens when some user decides to turn on a DHCP server on their workstation. Sometimes this can happen inadvertently, sometimes it can happen directly. And this can cause some severe issues because now when my workstation sends out that DHCP discover message, my rogue DHCP server, my unauthorized DHCP server, received the discover message. And it received the discover message before my official DHCP server does. So by the time my official DHCP server receives the original discover message, my rogue DHCP server right on that network has already given my workstation an offer of an IP address. My workstation then can respond to the rogue DHCP server and negotiate an IP address with it before my official DHCP server is actually able to negotiate an IP address with that device. So what do we do about this? Well, what we do to solve this is we turn on DHCP snooping. And the most fundamental piece of DHCP snooping is to create ports on the switch that are trusted to pass DHCP traffic, and then untrusted ports which cannot pass DHCP traffic. So then when this same event occurs and the rogue DHCP server responds to my DHCP discover message, when it hits that untrusted port, it's just going to throw that DHCP offer away and let the official DHCP server respond with the offer to my client that requested it. This is the most fundamental way that DHCP snooping works. What we can also do is we can actually keep a table inside the switch of which port is affiliated with which MAC address, which is affiliated with which IP address, which was learned from a certain DHCP server. So we can keep track of all that. And then what the switch can actually do for us is it will observe the traffic as it comes in and out of that interface, compare it to the information that it believes should be on that interface, and will only allow traffic on that interface to flow in and out. Now, all of this that I'm talking about right now is far beyond the ccna. What we really need to know here is that DHCP snooping is a thing, that we use the trusted and untrusted ports to make sure that we can avoid having a rogue DHCP server show up on our network.